Right, so we're going to clear up horizontal compressions, vertical stretches a bit more here. One of the transformations that students find particularly confusing. So we're looking at the difference between f of ax, where there's a factor inside the function, and the difference between that and a f of x, where there's just a constant multiplied by the entire function. I'm going to use an example that's not symmetrical around the y-axis. The reason people often find these transformations confusing is because they're looking at a base function like just x squared, which is symmetrical around there, which makes things very tricky because vertical stretches can look like horizontal compressions. In this example, I'm going to use x minus 3 squared. So I am sitting with the zeros of 3, a y-intercept of 9. If I look at, first of all, f of ax, one of the simplest things you might do actually is just to actually plug a number in. In this example here, I actually did f of 2x. So I just put 2 into the function. And that enables you to see quite simply, if you put 2 into that function, the function will become 2x minus 3 squared. Well, that's going to have a root, or a 0 rather, that is now 3/2, or 1.5, where it used to be 3. But if you put 0 in, you're still going to get the same result, so the y-intercept doesn't change. So this is really the key point for these horizontal compressions. The zeros will change, the graph will get squashed in from either side, but the y-intercept will not change. And one way you can think of it is divide all the domain or the input values. Imagine there's a table of values for your base function. On this transformation, just divide all the domain or the input values by a. So here I divided all the input values that corresponded to output values, divided them by 2, or multiplied them by 1/2, same thing. Now if you look at a constant outside the entire function, like 2f of x, that's just really multiplying all the output values by 2. So fairly simple there. If you had a table of values, you just double all the y values. That's a vertical stretch, but look here, here's the key. You are not squashing or shifting this graph in at all. The y values are the same here. So what we have here is the y-intercept has changed, and that got doubled to 18, but the axis of symmetry, or the zeros there, have not changed. They are still the same at 3. So in a vertical stretch, you just multiply all the output values by the factor of a.